You starting a scrapyard or?
No, we're standing here today looking at a John Deere LA engine on our what kind of weird stuff can you bring to Jamsey to try to stump them and see whether or not they can make something out of nothing. The customer actually brought in two of these engines. The other one is sitting over here. They're restoring this old tractor, and you know, it's kind of the usual story. Don't spend any money, but see if you can make us an engine that'll run. I'm assuming at least good enough to get them through the parade.
Why not do it as good as we possibly can?
We can't get any parts for this thing.
So we are going to do it as good as we possibly can. You just literally can't get parts for it.
We're going to do it as good as we possibly can on very limited parts. This has Babbitt rods. It has Babbitt insert main bearings.
So like the Babbitt rods, we would have to outsource that.
Yeah, all of that we'd have to outsource. I can grind the crank. I can turn it down minimum amount to get it round again, but we would have to outsource doing the rods and the mains. And I'm not even sure at this point where we would get that done. I haven't even started to check into that yet. But anyway, let's talk about the motor here itself a little bit, how unique this one is. These were made, this particular model, the LA, from what I'm finding out here, 1941 to 46. Little two-cylinder motor, about 10.5 horsepower, drawbar horsepower is what they claimed. Says it was actually tested at a little bit over 13. So you remember sometime back we did those little Massey pony motors. I think this is probably John Deere's. John Deere, they were always into these two-cylinder motors, and this one is a vertical motor as opposed to most of the other John Deere two-cylinders. The pistons ran horizontal.
And most of those other ones were overhead valve.
Overhead valve.
Overhead, sideways head.
It was over the piston.
Yeah.
This one here is a flathead style, but this right here is all it amounts to the engine itself, but we have this big huge casting out here on the front where they run the timing gears, and the bell housing is cast to it with this section here, and the starter goes in from the back, 6-volt starter on here, so it turns into a pretty big chunk of cast iron here for as small as that engine is.
How many cubic inch?
I think it said 77, if I remember right. Let me see, I have a sheet here that tells. Yeah, 77 cubic inch, 3.5 inch bore. Let me see if I can turn this thing over. This particular block, you see somebody marked on here 20. It's been bored 20 over on the cylinders. These two pistons here that look a little bit nicer are the ones that came out of here, the 20 overs. And what we're hoping is that this block over here is still standard, and we're hoping we can bore it 20 and use the pistons that came out of this one. But we'll have to see when we get there. Both of them, just to look at the crankshafts, they have quite a little wear on there. You can see some lines in there.
On this journal, you can feel
a ridge across.
Ridge across it.
Yeah, and I don't know if, can you hear that?
Yeah.
There's just a little bit of clearance in those main bearings. The other block's the same way. So I'll have to get this part, see how bad it is. I hope we can do something and tighten it up. There may be shims under these caps when we get in there that we can take some shims out and tighten it up enough to get the clearance into an acceptable range. But we have lots of parts and pieces here. I mean, there's pieces of the governor is here. You can see the flyweights on the governor. There's the cover for it. There's an idler gear here, thrust washers, oil pump. We've got two camshafts, so we'll pick out hopefully the best one of the two. Let's see what's in here. Oh, we actually have the old valve springs, retainers. Look, these have those little pins.
Yeah.
For keepers, which was very common in this era of engine. That valve lifters, a little bit rusty. But we'll have to try to clean them up, see if we can salvage anything there. Might possibly have to send them in, get them reground. There's a couple of different places we could use for that. This looks like maybe more what came out of this engine. They're not quite as rusty. They look pretty good yet.
Piston rings.
Yeah, looks like a new set of 20 over rings. A couple of cam bearings here. One of them looks to be fairly new. The other one, I think that's been on the shelf for a while, but it too is a new bearing. Brought us some bolts. There are some new valves. Nice shiny new. That's good to have. New valve springs. Looks like valve guides. Oh, yeah, that's the bushing for that idler gear we have down here. Must be for that. I would like to bake that block and blast it, get rid of all the rust and crud out of it. But when we do one like that, it ruins any bushings. So looks like we have the bushing for that. That's where the idler goes. And that smaller bushing is over here. Would that be where the governor?
Must be.
Yeah, I think the governor goes in on that. And then the cam bearings. So we're in good shape there. We can take those all out and bake and blast the block. Oh, and then he has a gasket set. That's kind of important.
Olson gaskets.
Olson gaskets.
That's who I got the gaskets for the generator from. I just haven't. We got to finish that project too.
Yeah, so it looks like, you know, even the front and rear seal. Sometimes that stuff is hard to come by. Let me get it apart here and clean some stuff up, and then we'll come back and see what we've got at that point.
Okay.
So since the last time we filmed our little introduction to our video here, I did make some phone calls, and I found a company out in California that says they can rebabbit the rods for us, and they can also rebabbit the insert bearings here for the mains. So, you know, remember, I don't know if you can hear that. That's how much play there is in those bearings. But before I take this apart, since we have two of these engines that we're trying to make one out of, and we're going to use the best parts of each one, I want to make sure I number my main caps. And underneath all this grease, these may already be numbered so we know which direction and which position they go in. But I'm going to go ahead and stamp another number on the front side here of each one, with me knowing that when I put it back together, that needs to go towards the front. And I'm also probably going to stamp a letter on there indicating, and stamp it also on the rail of the block here, indicating those caps go with this block, and I'll use a different letter stamped on there with this block so I don't accidentally mix the main caps up from one block to another. These blocks have a locking tab on every one of the bolts that holds that rear seal plate in place. So I'll have to bend those back first. Maybe a screwdriver would work better. Yeah, it does. Has a couple of dowel pins that goes over, making that kind of tight. We do have a new seal for that. So let's go ahead and knock the old seal out of there. That came out easy. Throw that away. Lock washers under the main bearing bolts. You don't see that on modern engines. And let's see what those bearings look like. Nothing unusual there. Insert type bearing. I'm hoping that is a bearing that can be rebabbited. It's not tore up or anything, but it does look to have a lot of wear. This one is a flanged bearing. Takes up the end play in the crankshaft. 1827 SB. You know, I think that is probably just a normal insert bearing rather than a babbitt bearing. I'll have to do a little research on that. Hopefully we can find some new ones if we were to grind the crankshaft. Lifting it out of there. Not as worn as I thought it might be. I can feel some wear across the journals, but not nearly as bad as I thought it would be. So let's set that aside. Pull these inserts out so we can save them. Okay, switching to our second block here. I don't know why those are so close. Yeah, they're just too close to get the socket on there. There it goes. Yeah, it's coming loose. See now if that's out far enough to be able to get the socket on it. And it is. There we go. There we are. A little bit different style than the last one, but it does serve the same purpose. Same way again. Has split lock washers under the main bolts. Same way here, bearing looks nice. It's not all chewed up or anything. No part numbers on this one. I think just worn. Back thrust bearing here, same way. A little bit of dirt embedded in there, not bad. I was kind of wishing these would have been babbitt bearings, insert type babbitt bearings, and I'm not sure if these can be redone or not. I'll have to check into that. Okay, looking at our crankshaft, yeah, this one feels like it's possibly worn more than that first one, but we'll have to clean them both up. We'll measure them up, see which one is the best. This is our block that is still standard bore size. This is the block, the one of the two that I hope we can use. I suppose we could sleeve either one of them to get the job done, but we was hoping that this block here could just be bored the 20 thousandths oversize and use our existing pistons out of the second block. Since we are going to clean this block, thermal clean it, meaning bake it in the oven and then blast it, I need to take out all these bushings before we can do that. I want you to notice that every one of them has a notch in the casting right above the bushing. Every one of these, little tiny notch, and if you look real close, you see there's a little notch in the bushing itself. See, this engine is pressure fed to the main bearings from the oil pump, but the only lubrication that any of these parts up here get is basically from splash. Whatever splashes out around this front main bearing sprays up in this area from the timing gears and dribbles back down into that notch, just gravity feed to each one of those bearings for lubrication. So it needs to be pointed out. It's very important when this goes back together and we put the new bushings back in there that every one of those gets in the correct position so the oil can feed back down in there. And you know what? Looking at this a little closer, I was wrong on that. If you look down in there, there is an oil hole and a passage. Looks like it comes across maybe over this way off of the main. So I guess those are pressure fed. Take that back. I was leading you folks astray. There are some other means to oil. Although this cam bearing looks to me like it is still just gravity fed whatever dribbles in there, maybe from the top side here. So this one here is pressure fed, but I don't think any of the others are. We'll see as I get into here a little bit further. You see, there is that notch I was talking about that we have to have lined up here for oil to trickle in there. And there's also a hole here that I think catches some oil as it trickles in from up in the valve train area down into that. Now this little bushing is a blind hole. I can't just drive that one on through. So I'm going to use a tap. I'm going to tap some threads in there. Now I'm going to screw a stud into it. Got an old wrist pin here I'm going to put over the top. And then I have a nut here. I should be able to turn that. And if things go right, look at there. Pulled that bushing right out of there. Wasn't that slick? There is a back cam bearing down in there. There, it dropped out of there. We're going to save that. We might accidentally have to put that back in. Through. There we have the back cam bearing out. Looks a little rough on the inside. Glad we have new ones. We have a flat type expansion plug here we need to take out. We'll be replacing that with new. There we go. Looks pretty good on the outside, but it's sure rusty on the inside. It's time to be replaced. We were wondering about the oil dipstick tube there, as far as whether it was steel or pot metal. And all we need to do is grab a magnet, do the magnet check, and there you have it. It's steel. That'll be fine to leave in. It will not melt. One more expansion plug here on the back. Let's get that out of there. That one actually looks like it's been leaking. These flat plugs like that, most of the time you can just hit them in the middle, drive a punch through them, and then pop them out of there. And I believe this one over here had better come out. There, popped out of there. And my gosh, it is just about rusted clear through, but we're going to save that so we can get a dimension off of it to come up with a new one. Look at all the junk that's inside this water jacket. Years and years of corrosion. Ready to go in our bake oven. We'll cook it, blast it, wash it up, magnaflux it, and see whether or not we're going to be able to bore that 20 over and have those cylinders come out. Well, I think it's time we move forward with our John Deere LA block here. I've got it out of the glass beater and spray cabinet. We blasted all the rust, all the carbon out of it. Washed it one more time real good to make sure we had the last of the rust and glass bead residue out of it. I've kind of looked it over here and everything appears to be pretty good shape for what it is. We're obviously going to have to put in some valve seats and some new valve guides because the guides are worn, seats are pitted, cylinders are worn, a little bit of rust in there, but I think the set of 20 over pistons we have will clean those up. So let's get this mounted over here on the boring machine and let's see if we can rough these cylinders out. So I have the boring head centered up on that first cylinder. I have my cutter adjusted so it should bore about 3.5 inch plus 15 thousandths, 15, maybe 16 thousandths, and then that'll leave enough material to finish over on the cylinder hone and make this a 20 over bore size block. So I'm going to go down so I'm almost to the top of the cylinder, and I should have measuring tape here. My cylinder length is about 6 5/8 inches. So I'm going to set a stop over here at that distance. That way when this boring head gets to the bottom of the cylinder, it should stop and retract back up out of the cylinder. So let's see what happens here. I think that bore size we can probably run, about 550 RPM. I would say is a good number from experience. There it goes through. I'm going to turn on a little vacuum over here. This will help collect some of the dust that comes out of that. Maybe we'll just mount it here on the top. Let's see what things look like. Wow. That cylinder completely cleaned. I'm impressed. Looks good. Let's move over to the next one and do the same thing again. Center this up. That cylinder appears to be quite out of round. Let's see if it'll clean up for us. Here we go. Let's take a look here. Appears that cylinder has cleaned up for us also. I know you can't see it on the camera there, but I can see some discoloration in here where there was a little bit of rust, but I don't think it's anything that's going to bother us. I'm guessing by the time we hone this, you won't even be able to tell. So let me put in a chamfer cutter here, and we'll take this sharp edge off the top of the cylinder. This will just feed down manually. Okay, right there I can hear it touched off on the cylinder. I'm going to guess we'll probably go down about 30 thousandths. Maybe not even that much. Looks like pretty good chamfer. Let's stop there. By the time I hone a little bit more out of this block and we deck the surface, some of that's going to go away. So if I put a little extra to begin with, I think it'll finish out nicer. Now I need to do the same thing to this first cylinder we was on. So I should be able to move back just by my DRO readings and hit the center of that cylinder again. So I'll bring this back to 0 where we started. Let's see what that does for us. So let's take it down to the 30, just like we did on the other one. And there we have it. Both cylinders are rough bored. That may be a little too bright down in there for you to see. I don't know if you can see on the side there's a little discoloration where there was some rust. But again, I think by the time we hone this, that'll clean up most of that. This engine will never see heavy duty use. It's more of a play toy than anything else, so I think it'll be fine. We do need to deck this surface yet, but I think I'm going to do the valve work first. Let's go ahead and do the guides and the seats, and then we'll come back and deck it. And once all that is done, we'll head over to the hone and finish honing those cylinders. I believe my next step on this block will be removing the valve guides. I'm hoping that I can just drive those out and press the new ones right back in without too much effort. I don't know if I have any specifications on these. This thing, I'm not finding a lot of information on it. So I'm going to measure my existing guides before I start. So what I'm going to do is zero my caliper on this straight edge bar I have here. I'm going to lay that across the top of the block, and then I'm going to measure down to the top of the existing valve guide, and I figure if nothing else, I can put them back like they were when they were brand new. 740 thousandths roughly. I wonder if those originally were supposed to be about 3/4 of an inch from the deck surface. Would kind of make sense. But let me try driver on here and see if any of these are going to move. And they are. Yeah, that came out relatively easy. That one's not going quite as easy. But it did go for us. I'm pretty impressed those moved. A lot of times guides have been in as many years as these have, and after we've baked the block, sometimes they don't come out that well. But we'll clean that up a little bit and see if it's ready for some new ones to go back in. My customer has supplied us with a set of brand new valve guides for this. I did a little research with some information I have here from Gen Sales. They sell service manuals for these older engines. And I did find in here where the valve says valve guides are replaceable, says press the guide to a depth of 3/4 inch from the top of the block. So with that being said, I came up with a little bolt here that I often use for a driver on odd valve guides. And I figured out if I put that washer and that nut on there, I come up just about, well, 742 thousandths, which in my book is plenty close to 750 thousandths or 3/4 of an inch. So I should be able to put that in the valve guide like that, drop these in, and probably tap those down with a hammer if they go in as easily as the old ones came out. So let's give that a try. I'm going to spray just a little bit of press fit lube inside the guide bore of the block. Put a little on my brush here. Brush that around, make sure they're coated good, make sure everything's clean in there. And then we'll spray a little bit on each valve guide. Drop those in. Whoa! That went out of there in a hurry. Didn't really mean to do that much, but we did. I should be able to tap that down till that's just flush with the top of that block, and that'll give us the proper depth. So let's see what happens here. Feel like they're going pretty good. This will probably trigger some people. And those are going just tough enough that I almost wonder if I should go over to the press. When I press this down in, as soon as I hit the deck surface with that piece of metal, we should be to the proper depth. And just for lack of something better, I have a socket there that we can put in there for a spacer. And let's see if we can get that down in there. Yeah, definitely more trouble than just driving it in with a hammer, but a little extra time now will save us time in the end and possibly some broken parts. So now we have the guides in, we probably better check the fit. Having just pressed those guides in, the valves go in, but feels pretty good there, but there's almost a little catch, a little bit of a drag there. The guides may have some high spots in them, so we probably ought to measure the valves themselves. The exhaust valve here is coming up about 0.3095. The intake actually looks the same, 0.3095. I do not find any specifications for how much valve to guide clearance they're supposed to be, but with that size coming up on the valve stem, generally the guide itself, if that's a 5/16 guide, would be 0.3125. So if I zero my micrometer here on that valve stem, move over to my little guide bore gauge, and let's zero it the same way off that size we've come up with. And now I check the valve guide. I'm about a little better than 2, maybe not quite 2.5 on that one. Close to 3, close to 3. You can see it's not as straight as it could be. So let's go in there with the hone and take just a little bit out of those, just to clean them up, not to remove a lot of material. In and out on this one. First 3 I'm right around at 2.5 thousandths mark. This one may be just a little less than that. There, now my pilot fits nice. And I'm going to go more by this because that is a carbide pilot. It is perfectly straight, perfect on size. And if it goes through there nice, I can count on our valves fitting those guides nice. From right there, I hope you can see that we have a lot of pitting in these valve seats, top of the deck surface here. They're quite worn, very wide, especially that one. A lot of pitting. They are just flat worn out. But I've taken some measurements here. I go inside that exhaust seat and I come up just slightly over, 5 thousandths over, 1.125 inches. And I have found some valve seats here, some of our SBI seats that we use, that are that same inside diameter, 7/32 inch deep, and just large enough there on the outside. I think that one is 1 3/8 to where it should clean up where it is worn there. On our intake side, we're measuring about 1 1/4 inch. Again, I found some seats that are 1 1/4 on the ID and 1.5 inches on the OD, 7/32 thick, and I think those will work real well if we make the counter bores and press those in. We should have new material to seat our valves into. So let me move this over onto the guide machine. We'll see if we can get that accomplished. So I've now mounted the block over here on our guide machine. I have a toe clamp on each corner of the block holding it to the table. I have leveled this block front to back, side to side. We're using a 1 3/8 inch OD seat, so I need the 1 3/8 inch seat pocket cutter. So let me put that in the machine. And we'll float over here, come down in the valve guide, and I'm going to go down till I just touch off on the top of that seat. I'll come down till I just touch off on the top of the block there. There we go. And I'll take one of my valve seats, put in up above here. You probably can't see that on the camera right now, but I'm going to put it in. Use that as a depth stop. And let's see here. I think we're looking pretty good on speed in the 400 RPM range. Probably ought to put a little lubrication on that pilot just in case. Here we go. Pop the air so it centers up nice. And here we go. Okay. Should be able to move over, do the other one exactly the same depth. Okay, change this cutter to do the intakes. Sometimes a little bit of pressure, kind of on and off, helps if you're getting a little bit of chatter. Okay, all of our seat pockets are cut. So there you have it. Nice clean seat pockets. I'll take my valve seat, it does have a beveled edge. Put that down. And just before it gets to the bottom, I like to blow it out, just in case there's any debris that have ended up underneath the seat. And there it is. You can hear it when it hits home. There it is. So there you should be able to see. We have all 4 seats installed. They fit real nice on the inside. Shouldn't have to do really any machine work to the inside of those. Of course, we will be cutting our seat angles on there. And I think before we do that, let's take that block over to the surfacer and we're going to deck the top of it. That way we can not only clean up all the gasket surface, but I did leave these seats, they're just barely below the surface. I'd like to surface this and make sure that if it's going to hit any of those, it'll clean those up before we do our actual seat area. So today I just finished putting sleeves in this Ford block here and decking that block. And while the machine was set up, from doing that one, I thought we'd go ahead and get the surface done on our little LA John Deere here. So I've set the block up on the machine. Let's turn the cutter on. Should be able to move over here and hopefully not hit. Yeah, that looks good. Let's zero everything here. And feed this down till it just touches. Okay, I can just barely hear that. 2.5 thousandths, that's 0 again. Back off. Feed down 2 thousandths. And engage the travel. And see how that looks. Okay, looks like it's made the first pass. Let's shut it off. And we need to make sure the cutter is off to the side, which it is. Release the feed. Bring it back across. Let's see what we've got. You know, that looks pretty good for a first cut. Actually, we could probably leave it like that. But there's a little rough stuff over here. Let's give it just one more cut. Maybe take another 0.02 off of it. Wouldn't hurt anything. See what that does for us. All right, we've made our second pass. 0.04 off the top of the block. Let's bring this back. Cutter's out of the way. See what things look like. Well, I'm going to call it at that point right there. Everything that matters on the surface is good. We can still see a little pitting inside the combustion area there. That doesn't hurt anything. But everywhere the gasket seals is good. We did touch the top of the intake seats. I must not got them quite as deep as I did on the exhaust, but the exhaust is right there. It's all but touching. In fact, that one almost looks like it made some marks across it. So we're going to call the surface good. So it's the end of the day, and I've had this LA John Deere mounted on Surrey for probably a week now. Nah, not that long, since last weekend. Getting ready to work on it. It's after supper. Thought I'd come back out, see what I get accomplished here. We only have the 4 valve seats to finish out. So I've put the correct size pilot in my tooling here. And I've got a 30-degree 3-angle cutter installed, and I have adjusted it so that when I'm in here cutting the valve seats, if we can see that there, it'll put on just the 30-degree angle. Probably won't be much on the inside. And I'm going to cut until I just see my 30 all the way across, maybe a little sliver of angle on the top there, and we'll call that good. So let me mount the camera on a tripod here, and let's see if we can get this done. I am not all the way there yet, but I wanted to see what this was looking like. And I have a funny line on there. I think my cutter needs sharpened. There must be a little chip in it or something. So let's back up a little bit here. I'll sharpen that and we'll come back again. Yeah, that looks much better. Kind of work those against each other and see what we've got. Aha. Looks like we could open that up a little bit and move our seat a little bit farther to the outside of the valve. So let me make that adjustment. Open the cutter up. I'm going to say that should get us where we want to be. And I think I could still go just a little bit more. I do like where that's at on the face of the valve. I hope that's where you folks can see. I like the way the seat has come out. So let's see if we can do the same with the other. There, I think we have both exhaust seats done. So now we need to do the same thing to the intake side. I can use the same cutting bit here on the intake that I did the exhaust, but we just need to bring it out for just a little bit larger diameter. So I'm going to give that a half a turn there on the adjustment screw. Let's check it against the seat. And what I'm looking at right now is I'm making my, right where it changes from the 30-degree seat angle to the 60-degree throat angle. I'm putting that right on the inside corner edge of that seat. I think that will make this real close to contacting our valve in the proper area. Okay, I can see we have just a little bit of the 60. Let's see how that looks. Okay, there on my valve. I would say that's a pretty good spot. I might be able to go out just a little bit larger. Okay, I've opened that cutter up just a little bit. Oh yeah, I like that. We're just a little ways in from the outside edge of that valve. Probably in the outer 2/3 of the face. My seat looks real nice. Let's go ahead and do the other one to match. I'd say we have it. .30-degree, 80 thousandths wide. Time to move on to the cylinder hone. We'll be done with this little block.
Okay, so we've got the LA in the cylinder hone here, and we're gonna try to wrap up machine work on the block real quick. This block is 3.5-inch standard bore. The pistons we have are used, but they're 20 thousandths oversized pistons. We're gonna finish on this to 3.520, kind of a nominal size there, and get this thing wrapped up. And just double checking here, this one we're in the range of about 3.518. This one I think has a little bit more wear, about just under 3.516. The book that we have for these pistons says 2 to 4 thousandths piston to wall clearance. So if we finish this right to that 3.520, between the two pistons we'll be kind of on both ends of that clearance range. So we should be in an okay spot. You got to consider what you're working on, the age of it, and using used parts, and kind of make a judgment call from there. And if we go to 3.520, we should be in a good spot. So we'll reset 0 on the bore gauge there. So now 0 is going to be our finished size here when we're honing this. So we'll take it to that finished size with the rough stones, and then we'll come back in with the finished stones and put a plateau on it. These are 180 grit diamonds, so they're kind of a coarse stone that'll remove material a little quicker, and it'll also get us those deep valleys that we're wanting to hold the oil on the cylinder wall and lubricate the cylinders. We've got a little bit of taper from boring the cylinders. We're about 4 thousandths to finish size at the bottom of the cylinders, and maybe 3 7 or 8 tenths at the top. That should straighten out pretty quick once we start honing. I don't know why I'm getting such a chirp, because according to the load meter, it's straight. Maybe just a little tight there at the bottom, actually. So let's overstroke out the bottom a little bit more. Sounds terrible. Well, if it's chirping, it usually means it's tight at the bottom or something. Okay. You can see how just after a little bit of honing, it straightens that cylinder out and our load meter goes still. I can't believe you can hone that long and it's cold.
Because there's more flow and thinner liquid.
So now we're going to switch to our 600 grit CBN stones. It's going to go in and knock the peaks off of the surface finish. Should leave behind those deep valleys for oil retention. While giving a nice flat, smooth surface for the rings to seat against. Now at this point, I'm just gonna do an even number of strokes on each cylinder rather than letting the machine hone to a certain size, because we're already at our finished bore size essentially. We just wanna come in and knock those peaks off, and it'll only remove a tenth or two of material. So now that we've got the finished stones, ran through it, we'll just check this with the profilometer. I'm sure the rings are very forgiving of a less than ideal surface finish, but just for fun. So yeah, we've got our valleys are honestly on the deeper side for what we would want for this application probably, but our peaks are about 15, that's in a good spot. Our core roughness is 45, that's in a good spot. Let's check the other cylinder. So there's a little tiny stylus in there that is tracing the peaks and the valleys of the surface finish of the cylinder wall. Pretty dang similar numbers to the other cylinder. In my opinion, on an application like this is the order of importance. Number one is your cylinder bore geometry. Is it on size, meaning there's no spots that are too tight? Is it round? And is it straight? Round is more important than straight, but I mean, all of these things are important. Then after all of that, is your surface finish. Especially on something like this, the cast iron rings that are going back into this are gonna be very forgiving of a less than ideal cylinder wall finish. But again, we checked it and I think we're in a good spot there. So let's just double check. So 2/10, 3. We're 2 to 3/10 larger than nominal size there. That one, you've got a spot that's maybe 4/10 larger. But both of those cylinders, and I guess I could check over this way too. I know the camera can't see it, but trust me, that is dead nuts round, if that's a thing. Cylinder finish came out good, and again, we're a couple tenths over the nominal finished bore size, but we'd rather be a little bit on the looser side than be too tight. So I think this is ready to get cleaned up. I think machine work is finished on this, so we can get it cleaned up and we'll start putting it together. Okay, so I think this is maybe the last machine work we have on the LA.
It is.
Okay, so we're finishing grinding, well, you are finishing grinding the main journals of this tiny little crankshaft.
Yes.
We'll put in the video, the short that we did of doing the rod journals, because we did that quite a while back, because we had to send off the rods.
We had to send off the rods, so we had to have those first.
Yeah, because we had to have Babbitt poured in the rods. Did that quite a while ago.
So this crankshaft here, the rods are a poured Babbitt bearing right in the rod. So we're gonna have to send the rods out to get those re-poured after I grind.
You can just grind those rods to whatever you want to.
Yeah, exactly. It makes it a little easier because I just grind till it cleans up, but I do need to make both of them the same to make it easier for the guy that's doing the rods for us. You can see the needle moving there. That's a low spot on the journal that hasn't quite cleaned yet.
Just a little bit.
Yeah. So we call that our 0. Wonder what size we really are. 1.740 and 8/10. Yeah, I definitely ground the worst journal first. This one probably would have cleaned up in about 5. I'm gonna call it right there. 1.740 and 7/10.
Be sure to like and follow Jamsey online for more.
And you were just, we'll put in the clips of you actually torqued the main caps on and measured the main bearings. And what's your strategy here making it come out?
Well, we ended up, I mean, it's almost impossible for the guy to get bearings for this, but he did find a set of 30 under, kind of sketchy looking main bearings, but that's all we had to work with. And I was just afraid that maybe they weren't exactly 30 under like they should be. And we have some pretty sketchy specifications on this. There wasn't a lot of good information out there, a lot of real old stuff that's been kind of compiled over the years for these engines.
So 1940s, they didn't have extensive hard drives and databases?
No, there were probably some databases, but it was hard to extract it down through your body and out your arm to the lead in the pencil.
Right.
So anyway, I just wanted to make sure, so we put the bearings in the block, torqued it down, measured them, and they did come out looking like if I grind this crank on the tight side of spec, we'll maybe be pushing 3/1000ths clearance. Okay. And the information I have here, where is it here? Or maybe it was on another page I found. I guess I don't have that here. That said 3/1000ths was an acceptable clearance specification for this.
Okay. So now you're just grinding to
the
tight side of spec?
To the tight side of what we have for spec.
Okay. Sounds good.
I'm going to take it down to where I think I have 10/1000ths left to go, and I'm going to measure again, make sure.
Okay. Well, we're not including as extensive of crankshaft grinding footage in this as we do sometimes, but there's plenty of videos on our channel of the more extensive crank grinding process.
Where that's all we did for the video was just crankshaft grind.
Yeah. So maybe this is what it looks like. That gauge tells him how much he's got to remove, and he works his magic and makes it happen. So maybe we'll get a clip of the finished product.
So today I was laying out my parts, thinking about maybe getting ready to assemble this LA John Deere, and I realized I have the head here and I had not surfaced it as needed. And here I am now in the middle of a setup doing these 6-cylinder John Deere heads, and I hate to break my setup just to do this head, so I'm going to cheat a little bit, and I'm going to mount the head on top of this head that I have already finished and surface it with this in place. But to start with that, I need to make sure that the head gasket surface here is parallel with the top side where the head bolts go. Plus this is a little rough around this water opening here, so it wouldn't hurt to surface this side just a little bit anyway. So I'm going to initially mount this head face down with one bolt through a spark plug hole into this existing 6-cylinder head. And I will snug that down. That ain't going anywhere. And let me adjust the camera a little bit here. And why don't I put a little color on this for you folks at home can see this better. So I'm just gonna put some of my red layout fluid there on the top of each one of those head bolt pads and all of this surface here that will be getting cleaned up. So you understand why I'm doing this. When I lay my level across this way, I am completely off high on the front side here. When I go across this way, I'm high over here on the right hand side. The two sides are not parallel, but we're going to make them parallel. And as you can see, we did not completely clean up. We touched here, crossed some of this over here, a little bit on that boss, and over here. But we still have all this around here and some of this to clean up. So let's make another cut. I think I'll take 10 thousandths. Well, even after that 10 thousandths cut, I'm still lacking a little bit here, and that is right next to the hole here where I'll be clamping that head down, so I want to make sure that's cleaned up. So we better take another 5 off here. Okay, with that, the surface is cleaned up, and we can flip this head over to the other side, clamp it down, and surface the surface we're doing all this for. Put the bolt down through the spark plug hole here. We'll snug it down tight. Make sure it's not going to go anywhere. Let's see if our level looks a little bit better. Yeah, we're more in the realm of things here now. Yeah, that'll clean up pretty good. So let me back this off a little bit. I'm going to ease into this, but I should be pretty much where we left off on the other side. So I'm going to go up to about the middle here. Feed it down till I just hear it touch off. Okay. I'm going to call that my 0. And let's feed it down. Let's take 2 thousandths off, see what it looks like. Yeah, it appears my setup may be just a little bit off. We touched basically all this area here this way, nothing over here. Nothing other than where there was a couple of burrs sticking up over here. Let's take 2 more thousandths and see what it looks like. That still didn't quite get it. Boy, it just almost. You can see here looking at that, it just ever so slightly skimmed this. It left, you can actually see the marks from the original surface on it. And of course it left some wear marks in here where the head gasket has worn into it. So I guess we're going to have to take another, probably at least 2 thousandths off there to get it. Okay, at that point, it has cleaned up everything except a little bit around here. Actually, that's inside the cylinder. That's not even where it's going to matter. That's a little bit of rust that has shown up inside that cylinder, some pitting there. So we're not going to worry about that. But my surface is a little rough to what I'd like. So I'm going to change that cutter bit or rotate it, and we'll make one more finish cut, and I think we'll have this done. There's a little bit of discoloration around here, but that's actually inside the cylinder where the gasket does not reach. Same way on this side. That's from condensation or water being in there, sitting over the years and rusting. But yeah, we have a good surface on there now again. Took a total of 7 thousandths off the head, so I'm very pleased with the results. So now that part's out of the way. I've got all of my parts laid out that I have for this little LA engine. Right here, I have our long-awaited connecting rods. We had to send these out and have the big end of the rods rebabbited. That's kind of almost a lost art, but we got a company to do these for us, and it took a little while to get them back, but they look real nice. And I want to show you how I checked those out. I took our micrometer here, and I measured. I can't do this and hold the camera at the same time, but I measured the journal on the crankshaft here, rod journal where I have ground them, and then I came over here to our rod bore gauge, and I set the micrometer up on the gauge here and adjusted it so that when I have crank diameter, I am on the 2 thousandths here. That's what I was hoping for clearance. And then when I take the connecting rod and place it over the gauge, you'll see I come out on the 0. So micrometer is up there on the 2 in the red. That's my crankshaft diameter. And the connecting rod itself is on the 0. That gives me exactly 2 thousandths clearance. The specification I found on this was connecting rod anywhere from 1 to 3. So that's going to put me right in the middle of specs. I'm real happy with that. And then I did something very similar with the mains. I measured what I ground my main diameter to. Then I took our bore gauge and I used that measurement, transferred that to the bore gauge here, so that when I'm right on 0, I can't show you that here and hold the camera. You'll just have to trust me. When I have the micrometer set on this end here, transferring the crankshaft main diameter to the bore gauge here, it comes out right on 0. And then when I place this gauge up into the mains, and I'm not going to do that for you one more time here because this bearing material is so soft that I'm leaving marks on it just with the gauge. So I want to avoid doing that anymore. But you're going to have to trust me, I came out at 3/1000 clearance, which is a little bit more than I really wanted to have. Again, on the mains specification I found was 1 to 3.5, so we're already a little bit on the loose side, but I'll guarantee with 3.5 thousandths in there, I won't be able to wiggle the crankshaft up and down like I could before we took this engine apart. They were worn so bad before. So with that being said, let me set the camera up here, and we probably need to put some bushings in here in various spots for the governor and cam bearings and whatnot. Let's get those in, and then we'll see if we can put the crankshaft in and see how it actually feels once it's in the block. I've realized that my back cam bearing, exactly, this is the new one here, this is the old one, they are exactly the same, but my front cam bearing, this is the old one, this is the new, it's a little bit narrower. I don't think that's going to cause us any problems. It's not ideal, but sometimes you have to deal with what you've got here. And actually, this old cam bearing had a notch cut in it here to allow some oil to come down from the top side here and lube the thrust surface there. There's actually a brass washer that goes in for the thrust surface there, so that's why that is cut in there to lube that. So I think what I'm going to do, since this bearing, this new one is a little bit narrower, I'm just going to press it in a little extra deep so that the oil hole lines up, and it'll just leave kind of an open area around the front here. These are a little bit hard to get at to put those cam bearings in. I was initially going to just drive them in with our old style driver, just kind of quick and get it done, move on. But I think I want to try our hydraulic installer we have from Bonafide Tools. It does happen to have an adapter that is just about the right fit for these cam bearings. So let me set this phone up, or set this camera up on a tripod, and let's see if you can watch how I do that. Whoa, sprayed it all over. That'll make my bearing go in a little bit easier. A little bit on the bearing itself. That's not quite centered. I'm going to put the wider portion towards the back. I think will work the best for us. So now, if I start cranking the little hydraulic pump, that should just pull that bearing right in, and it does appear to be doing so. Oh, I've run into a bit of a problem. My driver here is a little bit too large for the bore of the block. I should have checked that first. I will have to get a different driver to pull that on back the rest of the way. So let me go off camera here a little bit, and I'll line up some more tools. Okay, here's my plan. I found a valve seat, measures 1.625 on the outside. This opening is about 1.687 roughly. So I'm going to slip that over here first. I'm going to put the driver on backwards that I was using before to press up against that. Put on a spacer and the nut. And I think if I just kind of snug this into place, so let's see how that works. Go kind of gentle with it here. Yeah, there it goes. Let's see if that got us to where we need to be. And yes, it did. Appears to be exactly where I wanted it to be. Like I say, that bushing is back just a little bit, but this area will just fill up with oil from this slot here, plus what drains down from the valve spring area through that hole. It's not pressurized, it's just strictly drip is the only means that gets oil from. So now if we turn the block around, we should be able to do exactly the same thing from the other direction here. This time I'm going to spray it right in instead of all over my hand like that last one was. I'm going to double check with the mirror down here. I know you guys can't see that, but I think I can double check to make sure that hole is where I want it to be. And I'll have to put my valve seat over that first. I may have to have 2 of those valve seats to get this one in far enough. Let's go a few more pumps on the cam tool. And I'm going to guess right there is probably our spot. And I believe that's it. Let's take a close-up look at those cam bearings. There's the rear one. You can see here my hole may not be lined up just perfect with the casting in the block, but there's definitely enough there so it'll flow oil and lubricate fine. I have a nice fit on the front side here. Front cam bearing, holes lined up well, and this one being a little narrower than the original, we're going to leave an open area in here, but that will just fill up with oil and not cause any problem whatsoever. We do need to install a freeze plug or expansion plug in the back end of that camshaft opening there. I don't have a new one, but I do have the second block, the donor block here that we got the pistons out of. I'll just pop the plug out of it, clean it up, and use a little Loctite on it, put it back in. So don't let me forget that before we send this out to the customer. Looking at the other bushings we have to install in front of this block, this is for the idler gear, and you will notice that the replacement is a steel-backed Babbitt line bearing instead of the old bronze bushing like this had before. But that little notch is bigger, which doesn't hurt anything, but it has no oil hole in it. And that will not work. That's going to have that hole drilled in it. So I guess we better take care of that before we move on. So I took the old bushing and I lined it up here in the T-slot of the table. So then I took our new bushing, laid it in there, indexed it here so the notch would be in the same position, and then put a clamp over the top here, not with a lot of force because I don't want to distort it or anything, but just enough to hold it in place. Let's see what happens when I try to drill it. I'll just go easy with this. Hopefully it doesn't jump out of there. It's moving just a little bit. Now we're still okay though. Let's go on through the other side. And there we have it. It worked. There we have our hole drilled through. Needs a little bit of deburring work done here. It's on this end. So there's our notch and our hole. I think we're indexed just about the same. Let me deburr that and we'll be ready to put it in. I'm going to lay this bar across here, just use it as a straight edge to mark just where those oil holes need to line up. I can see down in here, you probably can't, but I can see down in there where the hole is, and I can also see the raised portion here in the casting where that is drilled down the inside. Get a little bit of press fit lube inside that again, it'll make the bushing go in easier. And while I'm at it, I'll probably just put a little over here where this bushing is for the governor that we need to put in. Remember, this notch here goes to the top side, so that little oil will drain down into that. Just give that a little tap to get it started. Oh yeah, I can look all the way through there. But knowing how tight that went in, I would say my chances of that shaft going in that to be almost zero. And I was right. I tried that bushing on this beforehand, and it really did not have much clearance. And as tight as that drove in, this won't even begin to fit in there. I hate to do this, but I'm going to drive that one back out and put the original bushing back in. I still have the original one here. What I do with it? It's over here. And it has a little bit of wear inside, but it's not really all that bad because I have no good way in my shop here to bore that bushing out and have a good bushing successful in doing that. It'd be a good idea to just give it a light coating here. Yeah, that's more like it. There it is. Nothing wrong with that. So that's taken care of. Now, let's see what kind of luck we have with this one. At least start it with that driver. There it is. Do you hear that? Will it still fit? Yes, it does. Just exactly like it should. Let's lay this back down and we'll put the crank in. So as you recall, we have measured all of the bearings while they were torqued in the block. So let's lay the crank down in here. If it will go down in. Yeah, so far so good. We've got some in play. A little bit up here. Usually it comes all at once and makes a mess. I absolutely could not find any torque specs on these. In the service manual we got from Gen Sales, it basically said tighten as required. I know that could easily stand to 80 pounds. So let's start with that, see what the crank feels like. I think back in the day when these were new, people didn't worry about an exact torque like we do nowadays. They could get by with just tight enough. It was a lot by feel. Now you'll notice I did not bump this crankshaft back and forth to align the main because there are little dowel pins for that rear main cap that should align it for us. And going by feel, I'm going to say we've got probably 5 thousandths in play anyway. Let's see here. In play, 3 to 7. Okay, everybody. I went to the trouble to set up this indicator so you could see it. And crank pushed to the rear, we're on 0. Push to the front, we're on about 5. There's 0. There's 5. Book says 3 to 7 thousandths, so we're about right in the middle of the range. Anyway, as a engine builder with several years of experience, I would grab this crank, pull it back and forth, see what it felt like, see how it turns. If it's in reason, I'd have let it go. But since this is the internet, I got the indicator out to show you that it is in spec. What do you guys think? Does everybody else always put an indicator on, or do you do anything by feel? I'm sure when this engine was built many years ago, probably out in the field, they were doing good if they just kept the dirt out of it. So let's move on here. I need to put the pistons on the rods, and let's see if we can get those in and if those Babbitt rods will fit the way we think they do. They're not the prettiest looking pistons, but I think they're fully functional, especially for an engine like this that's probably not going to see a lot of use. It's more of a toy than anything else. So with that, we need to put a little bit of lube on the piston pin end here, a little bit on the pin itself. These are a cinch bolt type rod. Has a bolt that goes in the pin end here and cinches the top end of the rod tight to the pin. And along with that, the pin has a little notch ground here that bolt has to line up with to go through there. So that does make them a little tougher to get lined up and on than some. But we should be able to just slip this in. That looks very close. Yeah, that one's most of the way there. Let's see if I can have that kind of luck on the other one. And in it goes. I'll run those bolts in and torque those down, and then we'll come back and put them in. We probably should check the end gap on the rings. Information I have on this says minimum of 15, maximum of 20. That ring there, I've got 16 goes in easy. 18 is pretty tight, so that's right in our range. Let's check the top ring there. Again, 16 goes in. 20 is really tight. I would say our end gap is about 17 thousandths, which is right in the range of where it needs to be. So let's see if we can get those put on the pistons now. These are some pretty tough rings to install. Definitely not low tension like what engines often use nowadays. So I have the expander, and then the two rails are opposite and kind of opposite each other. So now the second compression ring, look how thick that is. That must be a, see, what were those? Maybe a 3/32. I guess I could look on the package and see. And there should be a dot on here to indicate the top side. Yeah, right there it is. I don't know if you can see it on camera or not, but that's top of the second compression ring. So let's see if we can expand it out, get it over the piston without breaking it. There we go. And I'm going to put the gap in it on over the pin on the opposite side from where I have my gap in the expander. Then we have the top compression ring, which is a chrome ring, which is quite common on tractor engines because chrome is a lot more forgiving of dirt. And tractor engines are definitely operated where there's lots of dirt. Looking at this ring, there's no difference either side, top or bottom. And I'm going to put the gap opposite the second ring. Expander, the rail, second rail, and into the second groove, and over the piston we go. These Babbitt rods not only are harder to work with because of the way you have to repair them, but they also have shims in here. So for instance, this one is, that's cylinder number 2. I don't want to start with that one. Let's start with number 1. Yeah, this one's marked number 1. They have shims in there in between the cap and the rod so that on down the road, as the bearings wear, you can actually tear this engine down and take out layers of shim. So we have to be very careful with these that they get put back just as they are. And those bolts are loose in there, so let's go ahead and I guess that one will stay. So let's lube up cylinders just a little bit. I like to take a little of our assembly lube and coat the top of the cylinder, and then when we shove the piston in, it will pull the lube down the cylinder wall and lube up the lower portion of the piston. We'll put just a little bit on our bearing here. The instructions said the cinch bolt needs to go on the same side as the camshaft. So that would be like that right there. Piston's going in. How about that? So those are actually 1/8 inch wide rings, 125 thousandths. And I think we have performance engines out there that are running rings that are down in the 30 and 40 thousandths thick. That's just unbelievable how much ring technology has changed over the years. Okay, I'm gonna have to be real careful with this so I don't ding the, well, and of course the bolt came out now. It was stiff in there before, but now it popped out. Okay, so let's go ahead and bump this on down to the crankshaft. Got to make myself enough room here to work. There. Okay, so now let's double check and see if we have everything turned the right way. Get my little flashlight here. So the camshaft is on this side, and yes indeed we have the cinch bolt on that side. So let's get our bolts back in there. Those are actually laminated shims. I didn't measure how thick that was, but you can generally peel off layers of about 2 thousandths per layer. I remember my dad talking about old cars back in the 30s, working on them and taking up the bearings. He said they would come in and he would put a new set of rings in them and take up the bearings, and then you had to tow them around the section to get them to turn again because they had the crank was so flat with all the tight spots in it. And he said, when you got done, sometimes they smoked just as much as they did before. I always thought that was funny. I'm not going to go to full torque yet. I think I'll go 20 pounds just so we can get an idea of what things feel like. Yeah, that feels good. And these also have, they're drilled with castle nuts on there. We'll have to put cotter pins in there to lock those on when we get them torqued up the way they need to be. Okay, let's see if we can put the other one in. There it is. There it is. First shim on that side. Second shim for this side. Okay, there's 20 pounds. Uh-oh. That one we locked up. Why would that be? Interesting. So we're going to have to investigate that a little bit more. It's been a long day. I think this is a good stopping point, and we'll kind of figure that out and pick up the video later. I could turn it when I put in the number 1, but as soon as I put in the number 2, I could no longer turn the engine. Something was tying up. We had measured the crank journals and compared them to the ID of our new Babbitt bearings here, and I was quite pleased with the clearance had there, but I overlooked checking the side play. And what I found is we had to go off camera. It was late in the day, I was tired, I was frustrated at that point that all of a sudden we'd run into stumbling blocks, so it was time to quit for the day. Went off camera, took this back apart, made some more measurements, and found that my number one rod cap here, number one rod bearing or rod and cap, I actually have excessive side play clearance. When I move over to the, try that on the number 2 journal here, same thing, excessive side clearance. I actually got the calipers out here and tried to measure the journal width there, and I'm coming up about 1.125 roughly, inch and an eighth. And same with number 1. They're both very close. It may be, I'm coming up here. No, I come up the same thing, 1.124, 125. So my journal width, they're both the same, but for whatever reason, this, my number 2 bearing cap and rod, does not have any side play. It is just about exactly the width of that journal. And once you put it on there, torque everything down, I could forcefully turn the crank, but it was not the way it should be. If I'd have tried to run it that way, they either wouldn't have been able to turn the engine, get it started, or else it would have heated the bearing and taken it out right away. Again, there's my number 1. You can see how much side play I have. Number 2, nothing. In fact, if I push down on there, I can feel it starting to get kind of tight on the journal. So what we're going to have to do is figure out a way to bolt this rod and cap back together again and set this up and face off the sides of the thrust surface of this rod. Well, our actual spec, I found something in an old book that said 2 to 10 thousandths side play. This number 1, we've actually got probably closer to 20. And side play is one of those things within reason that too little is a problem, but too much won't make any difference whatsoever unless it was to the point that it moved over and opened up a passage so the pressure from the oil hole there would seep out the side. I wish it wasn't this way, but it is. We're just going to have to deal with it. But this one here, I think we can set it up and figure out a way to face a little bit off the side. So with that being said, I'm going to go off camera again, see if I can get this set up on our boring machine over there, and at that point I'll bring the camera back on so you can see what I'm trying to do. We're going to make a lot of assumptions here. We're going to assume that the sides of this rod where they rebabbited were cut square, perpendicular to the center line of the crankshaft. So I've clamped that down against the table here using one of the rings here for our rod machine, normally used for resizing the big end of rods. So I've clamped it down here. It's solid. I've put in a cutting tool here that should face the side of that rod off when we come down inside here. And I think what I want to do is try to take maybe just 3 or 4 thousandths off this side, and then I'll flip the rod over and we'll take an equal amount off the other side. I'm going to put a little bit of color on that rod, not so much for you guys, but so I can see. You know, I have never done anything exactly like this. So this is a first for all of us. I'm just going to carefully feed this down until I touch off. I'm not sure how close I really am. Closer than I thought. Okay, I don't know if you guys probably can't see that down in there, but I'm touching on 2 opposite sides here at 1/1000th of an inch. This is actually working very nice. And I'm sure there's some of you saying, why didn't you send this rod back to the guy that did it for you? Well, I would have loved to have sent it back and let him touch it up a little bit. But you know, he is 1,000 miles away. And if this is something I can make work right here, why waste the time and bother of doing that? It's much easier just to take care of it. All right, so from the time I first touched off, that has gained me about 5/1000ths of an inch. So I'm going to stop right there and come up out of there. And I'll do the same thing from the other side because I want to keep the chamfer that's inside the rod there as much the same side to side as I can. There is a little spot right here that didn't touch off. I think this, it all but touched. But on the high spots, we've got about 5/1000ths off there. There's 3, 3.5, 4, 4.5, and I'm going to stop at 5. I'm wondering if maybe that got overlooked when these were done. But let's go over, and I'm going to put this back together, and we'll see if the crank turns now. I want to show you that we do have them torqued. We do have side play on number 1. A little bit excessive, but it'll be fine. It's not a big issue. More than I'd like, but you don't always get what you want. Our second rod has given us so much trouble. Again, it is torqued. We have side play, a more acceptable amount. It's more in the range of what I would expect we might have on that. And I want to show you, this does turn over nice and free. Everything should be fine at this point. So I do need to put some cotter pins in these. They do have holes drilled with a castle nut to lock those on. So I'll get those in there, and then we can move forward with putting the valve train together and all the front cover on. I think we'll use a little bit of our driven assembly lube on the lifters. Put a little bit on the face here. I did number these when I took them out. Looks like that's number 4. See if I can reach down in here and get it in where it belongs. A little bit of a tight fit for my hand down in here. There, it's in the number 2 position. And there it's in. Now then, this does use a brass thrust washer behind the cam there. So I think we can use that same lube on it. Put some on both sides. Drop it on. Bearing guard assembly lube on the cam journals. So the camshaft is in. Oh, that's plenty. Got enough on there for several valves. Okay, there they are. Valves open and close. You have to pull the valve back. You have to make sure the lifter is on the base circle of the cam. You don't want it pushing up this way, giving you any less clearance. But I really don't know any good way to easily get these springs in other than you have to make sure it's all the way down in the pocket and put the retainer on there and then just flat pull them down and see if you can get them to go over the end of that valve lifter. There we go. Okay, that one's in. And then you push the valve back down in, get it to go in the retainer. There we go. That one went a little easier. Flathead engines are just kind of hard to work on sometimes compared to an overhead valve engine. Finger muscle, yeah, to pull that down in, there it goes. And there it is. So I found my dad's old valve spring compressor tool. I really don't know how old this is. It's something that he had from years and years ago. There is the newest patent date on here is July the 10th of 1923. I don't know if that would show in the camera here or not, but July 10th, 1923, made in USA is when this was patented. But anyway, this tool does do a pretty good job on these old flathead engines when you have to get the valve keepers in and out. There's just a hole in the end of the valve here that a little pin goes through to hold the retainer in place. I can reach down in there and get that in place. Oh yeah, went right in. So now I release the tool, and there it is. There it goes. Release the compressor. So now I should be able to go through and adjust the valve lash at this point, and then we could probably put the head on the engine. You need to make sure that the camshaft is on the base circle of the lobe when you adjust the valve. So there, my exhaust valve, I'm turning the camshaft here, my exhaust valve is opened and is closing. Now my intake valve, if I can roll it around here, has opened and closed. And that brings me back around to where I'm on the base circle of both of these valves. So I have an 8/1000 feeler gauge here. It's very loose in there right now. So let me get a couple of wrenches on here. Luckily these are self-locking adjusting screws on here. Some of these old engines actually have a lock nut on there. You end up having to use 3 wrenches to try to adjust the valves. And I'll tell you what, that is a bear cat. I feel sorry for the old buzzards that used to work on these things back in the day when that was the norm. Would not have been much fun. Adjust that so I just get just a slight drag on the 8/1000. I'm going to check it against a 9/1000. Yeah, there we go. 9/1000 is quite tight. 8/1000 is free. Let's do the exhaust valve on that cylinder. So I'm going to use a 10 and 11 to get my feel for that one. Yeah, 11 is tight. 10 will still go in. Say we're probably very close at that point because the 8 goes in, but the 9 is tight. Okay, 10 is free. 11, I have to force it. So there, we have the valves adjusted. I think we can go ahead and put the side cover on, and also we'll put the head on. So let's lay the gasket on there, and a little cover. Customer that owns this engine painted up several of the covers. They're all shined up, painted up, cleaned up nice. Just kind of tighten that by feel. Maybe after this engine has been run, heat cycled a couple times, they might be able to come back and snug that just a little bit more. So something we always do on our valve jobs is the vacuum test to make sure the valves hold. And if I hold my finger over my vacuum plate here, and you watch over there, let me do a different finger here. You watch over here on this gauge, you can see the maximum amount the needle will pull at our altitude here. And when I put that over my port here and check the valve, you can see that the needle virtually goes to that same position. Now keep in mind, there is a little bit of vacuum you lose up around the valve stem and the guide. You'll never have a 100% perfect seal, especially on an engine like this, where there are no valve stem seals at all. But you can see there in checking that valve, the needle on this gauge virtually goes up to the exact same amount as if I was just holding my finger over the plate here. When I turn the vacuum off, you can see it just about holds, but like I say, there is a little bit of leakage probably around our gasket here where the plate goes on, and also up through the valve guide, which is perfectly normal. So our valve job checks out. Let's go back, put the head on. The bolt holes, bolts all go through completely down into the water jacket. So we're going to have to put sealer on the threads. The head gasket is kind of a fibrous material on the top side. The side that goes against the block, like this, is all metal. And back in the day, we always used silver spray paint on those. So I've got some silver high temp engine enamel here. I'm going to take this outside. I'll spray a light coat. Okay, this spray doesn't look much different on the camera, but I did spray a nice even coat of silver engine enamel, high temperature engine enamel on that. So we'll lay the head gasket on here now. We should be able to just drop the head down over that and keep things lined up better. How's that for using your noggin? So I'll apply a liberal amount to them. I did not find any specifications, any torque specifications actually whatsoever for this engine. Our books just come up blank. Everything said just tighten, basically common sense, tighten tight. I'm going to go with 75 foot-pounds on these head bolts. If somebody knows different, I'd appreciate leaving us a comment on that. If that's entirely wrong, I think that's a pretty good number. No torque sequence, but the general rule of thumb is you start in the middle and you work out. That way it kind of flattens or stretches the head gasket out evenly. So I'm going to start right there in the middle. I'm going to go here, 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 there, 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 and there. You can see around the edges here that silver paint squeezed out. There, I think that's good for right now. So the freeze plugs on this engine, you put a little sealer around them, stick them in, take a driver, you hit them, and when you flatten out that curvature with a hammer, it makes them expand into the opening here. Sleeve and bearing retainer around here where they go. There went my driver. And I can see that has somewhat flattened that plug and expanded it in, so it'll be tight. We'll never come out of there. And I'm going to consider that good. So at this point, I have finished seating the crankshaft timing gear onto the crank. We do have our marks lined up. Also, something I want you to see here, I laid the block over flatways here upside down, but if you listen real close, you should be able to hear me rocking that cam back and forth, proving that we do have just a little bit of backlash. So earlier in this video, at the point we were torquing the main caps on, I did not have the required lock washers that go under the main cap bolts. And I said we were going to come back to that, and I'll bet you people think I forgot all about that, but I didn't. So I think this is the point we better get those lock washers on and get the mains torqued the way they should be. So we'll put lock washer on each bolt. Since these are a 9/16 12 thread per inch bolt, back at the time this was made, bolts were not built to the same standards that they are today. And I'm going to go with my gut feeling that 100 foot-pounds will be about the correct torque on these. So let's see if I can get these pulled down to that. Main bolts are torqued with lock washers. Crankshaft is still nice and free, just like it was before. This old engine used cotter pins on the rod nuts. So let's see if we can get those put in. Nut has to be lined up with the hole in the bolt. There we go, that one went in. And when you bend those over, bend the end of that over to lock those in place, everything has to fit tight there. You don't want that cotter pin to have any slack in it, because if it's sloppy in there and moving around, it will wear itself out, believe it or not. That's something I learned from my dad years and years ago, because he was just an old farmer, but he did all his own mechanic work and was a pretty sharp old guy. That first one is in, locked in place, and fits snug, doesn't move around. There, that one too is snug. I don't know why it is that these old engines, they used to think that they had to put cotter pins on the rods, because obviously we don't do that today anymore on modern engines. And I think they run under a whole lot more stress than any of these ever did. That one seems to be locked in place. There it is, snug in place. So there are a couple of fittings that go into the main caps here. The oil tube goes in between. I'm wondering just what we're going to have to do to bring this all together, because I do have the oil pump here. We've had it apart, completely cleaned it, everything looks good. Just got it lubed back up, and probably should put a little bit of lube on the gear itself. But this may be a little bit of a trick to get the oil pump in and this tube all together. Maybe this needs to kind of start at the same time. I have a feeling this is one of them things when everything gets in just the right place, it'll probably screw together real nice. And until that time, I'm probably going to fight it. Let me get a different pair of glasses on here. Maybe I can see it a little bit better. Yes, look at that. It's going on just as it should. Okay, I'm going to leave all of those loose, because the other thing we have to do is get the bolt in the side here that holds the oil pump in place. And that uses a tapered screw here with a lock nut. It appears the oil pump is just about where it needs to be. Okay, I'm going to put just a little bit of Hylamar sealer on these threads. Think that might be a wise idea. Otherwise, the oil could seep past the threads and have a leak here on the side of the engine. Now, if this works right, you should be able to see the oil pump kind of slide on down into place as this screw wedges into the side of it. Tighten that tight, and then we'll put the lock nut on. Probably 50 pounds of torque on that lock nut should hold it in place. Okay, so there, the oil pump is in where it belongs. I just need to finish tightening the lines. That should be tight enough there. Good there. Okay, I'm going to call that good. So maybe we should attempt to put this rear seal on. It does have a full round seal that I earlier pressed into the housing here. I did that off camera just because I can't possibly show everything on here. And there is a gasket that goes on with that. So I'm going to put just a very, very thin coating of silicone sealer. I wish you could get this stuff in an aerosol spray. I think that would be a wonderful product if someone was to come up with that. I'm going to put just a little bit on the inside lip of this seal, because you don't want the seal to be dry on the crankshaft, because it will get hot and stick to the crank before it gets lubrication if you don't. So I'm going to carefully slip that up over the crankshaft now. There we go. You probably can't see that, but it'll grab the sides of that housing, and then when you bend the other tab over the head of the bolt, it'll keep it from ever coming loose. This is something it'd been nice to have had brand new ones to do the engine with, but things like that are not always an option. Should keep those from ever coming loose, especially along with the Loctite that we put on them. There. We have the rear seal in. We should be ready to put the front cover on after we get the rest of the gears in here. There is a oil slinger that goes on the front of the crank here. I want to note here that we do have our timing marks lined up before we cover that up. There we go. There's an idler gear that goes in here. Oh, and I got lucky. That will clear that slinger when I drop that down in here. We need to put a little bit of lubrication on it. And there is also a thrust washer that goes on with that. So we'll slip that into place here. Now this idler gear does not need to be timed. There are no special marks or anything for it. It just drops into place. There we go. There it is. Got a little bit of backlash there. Governor assembly. It has a little thrust washer, goes over the end there before I drop it into place. Have some lubrication in there when this all first starts up. This bearing also goes in here, and the faster the engine runs, the more force these exert, and you can see they push that bearing back and forth, and that's what controls the engine RPM, all with those flyweights. Pretty interesting deal. Little thrust washer, and we'll drop this down into place. And again, there is no particular way it has to go in. It does not need to be timed. The only gears that need to be timed is the crank gear and the cam gear. The others can just go in wherever they go. So that does have to be free to slide up and down on that shaft. So I believe that's everything that goes on the inside. However, I have not put any lubrication on the gears themselves. Let's just go ahead and drop some around on that. You can see as that comes around, that lubrication starts working its way into the gear teeth. If you'll notice, there's a little button kind of looking affair on the end of each of these gears. The front cover, when we put this cover on, you'll see these two spots here. There are little kind of like set screws with a phenolic button here in the end that we have to adjust down against those to set the end play. And you'll see that as we move forward here. I'll put a little lubrication right on the end of that for the buttons. I'm going to put a really, really light coating of silicone gasket sealer all the way around this gasket before I put it on. If there's any imperfections in that cover, which I know there are, it is not perfect. This here will hopefully fill those in. Silicone gasket sealer is an amazing product used sparingly. We do have a dowel pin there and another dowel pin up on this corner. Again, you can see these two holes where the set screws go in. Let's see if I can get this to go over the dowel pins. There it is. Here is the rest of our governor mechanism. This bearing assembly pushes forward. Well, that in turn pushes on this little arm back in here and makes this linkage work. This here goes back, connects to the carburetor. Pretty ingenious device. Drop the gasket in place, set the governor assembly on there. There we go. And 3 more bolts. 4, 5, 6, 7. And my feel good bolt here. Yeah, that feels good. So I drove the roll pin, actually it's a solid pin, back out of the way here. Now my customer painted up odds and ends of pieces here before he brought this to me. He'd been working on this himself. Some of the parts he cleaned up, some of them he didn't. Some of them he left it for us to do as far as the block and the machine work. He did paint this. There is some paint on the inside there. I'm hoping it slides over okay without having to clean it up. And actually it does. So I'll just slide this down till I can see the hole lines up. And then I should be able to tap the roll pin in if I have it lined up correctly. There, the pin is in. You see a lot of these old engines, the bottom pulley is just held on by a roll pin like that rather than a press fit onto the end of the crankshaft or held on with any type of a bolt. Low RPM, not a lot of stress on that. The only thing this would run is probably a water pump and maybe a generator. So right here in this position on the block is the oil pump bypass valve, which consists of a plunger and a spring and a nut that holds this assembly all together in there. And what happens, this plunger on the end here goes down against a seat inside the block that's machined in there. And when the oil pressure becomes too great, it pushes this plunger back, compresses the spring, and regulates the oil pressure. I didn't look in the catalog to see what pressure that is supposed to be, but with just the spring and the plunger in there, if the pressure is still not high enough, you can add little spacer shims into this cap. And it just so happens when we took this engine apart, there were 3 of them in here, which I think is a little bit excessive. I'm guessing somebody had put those in there trying to make up for that loose bearing clearance we saw on the crankshaft there. But for right now, I'm going to put it back just like it was. And once the customer gets this engine running, if his oil pressure is excessive, he'll have to take this back off and take some of those shims out. There is also a gasket that goes over this assembly to seal it so that it doesn't leak. But I think the customer will probably have to take some of those back out because I'm anticipating this having a whole lot better oil pressure than it had before. Now we have a nice fresh ground crankshaft and tight bearings. But anyway, it's just a matter of sliding this down in, screwing the nut down tight. There, that should do that. So now I think we can turn this over upside down and we'll put the oil pan on. So I think this is the last item I'm going to install on this engine. We have a nice shiny, clean, it's been primed on the inside, painted with the green on the outside. Our customer did that. He did a real nice job painting these parts. Looks real good. And hopefully this is the last time I ever, in my lifetime, see inside the bottom of this engine. I want to look at things here one last time. Is going to kind of roll it over and make sure things look like they're working the way they're supposed to. And it does. We have a little side play on the rods. They felt good. We have a little bit of in play in the crankshaft. Oil pump is all installed. Nuts are all tight. I think we're ready to put the gasket on here. This has just a thin paper gasket. Pretty narrow area across the front cover here to seal up. I'm lucky our pan is nice and straight, but I think I'm gonna, just like I did on some of those other parts, put just a thin layer of silicone on this before I put the gasket on. Something like that. All the way around on this side of the gasket. And again, I don't want so much of this on there that it's going to squeeze out and leave big old blobs hanging on each side of the gasket. I want just enough to seal any imperfections we may have here, because we are dealing with some rather old parts. No telling how many times this has been off, on and off. Every time you take a tin cover on and off and retorque it again, it adds more distortion. Although this one looks really nice, this pan looks really nice and straight. Okay, that paint customer used on this seems to be kind of brittle, and everywhere that it gets torqued up against a bolt head, it seems to want to chip off. I always prefer to paint everything after I'm completely done, just paint it as an assembly, because he's going to have to go back and paint a lot of this anyway. So that the, if nothing else, the heads of the bolts are covered. So let me blow that off, because there are a lot of flecks of paint. Okay, one last thing, we need to tighten the drain plug. And again, I'm going to put a little Hylamar sealer on that. It does stay flexible. It doesn't dry and get hard like some sealers might, and that should keep this plug from seeping without having to be overly tight. And we'll grab a wrench there and tighten that up. There we go. And with that, I think I'm pretty well finished with anything I can do with the pieces the customer brought me for this engine. That completes my part of it. He'll have to take this home and finish it up on his own. Okay, folks, if you are watching this right now, seeing me spin this completed engine around, that tells me that Nicholas was able to take all that footage I made by myself, with the exception, I think he did some of the work along the way on a couple of different components, but most of it was me by myself here. That tells me that he was able to turn that into a video, and I gotta give you guys credit for staying with me the whole time to the point we are right now, where I have as much of this engine assembled as the customer has brought me parts to do. You know, we went through ground to crank, bored the cylinders to fit some used pistons. We sent the rods out, had them rebabbited, got those to fit correctly, did the valve job, new seats, guides, and put this engine all back together to this point where customer should be able to take over from here. He'll have to clean it up a little bit. I did get some oil on the outside here. He'll have to clean that a little bit, and he can paint this and get it back in his tractor, and hopefully the entire tractor will look as good as some of these green pieces here that he had cleaned up for me and painted before he brought these in. So anyway, we appreciate you people watching this. Make sure you like, follow, subscribe. You know the routine. I just gotta say we appreciate you being out there and watching this stuff. It's fun doing these videos on an engine like this. And obviously, an engine like this, the hours that we put in, there is no way we could charge the customer enough money to cover what it takes to do one like this. But through our viewers here on YouTube, that allows us a little income on that side to compensate for what it takes to do these engines. So anyway, thank you very much for watching. Go to our out there and follow that link to our site where you can see our merch. You might want to buy some of our merch. Be fun to see you guys wearing it out in public sometime. So see you later.